Okay, let's give you guys some more practice. So here use Riemann sum to work out the area of this function between 0 and 1. So work out this area here. Okay, so this here is 1 and this here is 1. Okay, so press pause and have a go. Okay, so the normal routine is to get the whole distance here, cut it up into n number of strips. Okay, so our normal routine would be this. So this here is our normal routine. We get this whole length here, so it would be b take away a. So in this case here, it would be 1. So in this case it would be. So in this case, this whole length here would be 1 take away 0, which is 1. And then cut up into n number of slices. Okay, so 1 over n represents your delta x. So your delta x is this length here. This is delta x, and this is delta x, and so on. So each strip here has a width of 1 over n, and then the coordinate right here, the x coordinate right here would be 1 over n. Right here, it will be 2 times your delta x, because it's 1, 2. Okay, so this point here is delta x, and this here would be 1, 2, 3. So this point here will be 3 times the width of this strip, and so on. So you can say that this area here, this whole area here, is approximately so the first strip here, you need to know the height. Well, you need to know this length here. You need to know this length here, the height. So the height would be you putting this into the original formula. So if you have the x coordinate right here, if you put this into here, it will jump to this point here. So which is your height. Okay, so the height of the first rectangle here, the height of the first rectangle. So this here is your height, because you're putting this into the original function here, and so on. Okay, so this is your height, this is your width. So you can say the average. Sorry, you can say the area is approximately all this here. Okay, and then it's and then you can rewrite this as this. So this is much simpler and neater. And then note, so whenever you see a summation here, it is a k that's changing about. So this here is a constant, so take it out here. So that will then give you this. Okay, and remember that our original function was this. So for you to evaluate this, you had to put this into here and then square it. Okay, so put this into here. So that will then take you to here. Okay, and then now it's just a matter of tidying this up. So this squared will be this, and then you can break into here. That will then give you this and this here, and this is a constant. So n times a constant, that will give you the n, and visualize this bit here as a constant. So this is like a 1 here. So you can take it out here. So this thing here is quite complicated. Take the constant out. So it's like a 1 here. Take it out here, and then you can just concentrate on finding out the summation of k squared. It's much simpler. This here is much simpler than this. Okay. So it's blah blah blah. And then this times this, that will give you this. This times this whole thing here. Don't forget, it's top times top. That's a third. And then bottom times bottom, that's to the power of 3. Remember, it has to be to the power of 3 here. And then remember, there's a formula for this. So which happens to be this here. Okay. And then blah blah blah. This n here gets cancelled out with one of the n's here, giving you 6n squared. And then that would then take you to this stage here. So you can say the area is approximately the sum of all those strips. But then now, so currently here it is the area is approximately the sum of all the strips. So now make n take the limit as n tends to infinity, meaning increase the number of strips to an infinite number of strips. So you can now say the area is equal to this whole thing here. So now it's just a matter of working out the limit of this, which will be blah 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 here, blah blah blah, blah blah blah, and then blah 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 blah, and then it equals this. Okay.